Hello and welcome to Geek. In today's video we're going to be talking about the atom. Atoms make up everything and they are unimaginably small. So small that we need an electron microscope to see images of them. And learning the structure of them was a discovery that shook scientists to the core. Rutherford's alpha scattering investigation showed us that the atom is made up of a small positively charged nucleus surrounded by negatively charged particles, which are electrons. In this investigation, he fired alpha particles or helium nucleuses at a thin material, which is usually gold foil. There were detectors placed around the room, and they showed most of the alpha particles travelled straight through the foil. But a small number were deflected by large amounts, and a tiny number bounced directly back. This made scientists conclude that most of the atom was empty space, with this tiny region of concentrated charge, and that region must be of the same charge as the helium nucleus, positive, which explains the backscattering to be caused by repulsion between similarly charged objects. 99.999999% of the atom is empty space. An analogy I love to use to help people conceptualize this is if you go to Wembley Football Stadium and place a garden pea in the centre, that pea would be the size of the nucleus, and the total size of the atom would be the entire stadium. Another great one is if you squeezed all the empty space out of all of humanity, it would be the size of a sugar cube. Later experiments showed that there are two types of particle in the nucleus, the proton and the neutron. As you can see in the table, the electron has a much smaller mass than the proton or the neutron, and the proton and neutron have an almost equal mass. The electron has an equal and opposite charge to the proton, and the neutron is uncharged or neutral. The total number of protons and neutrons in a nucleus is called the Nucleon number. This is represented by the letter A. The total number of protons is called the atomic number, represented by the letter Z. This is called isotope notation. An isotope is an atom of an element with the same number of protons but a different number of neutrons. An ion is a charged atom. An atom becomes an ion if it gains or loses electrons. If an atom loses 2 electrons, the atom is left with a +2 charge. If it gains 2 electrons, it's left with a -2 charge. So if we change the number of neutrons, we get an isotope of the same element, but if we change the number of protons, we get a different element entirely, and changing the number of electrons gives us an ion. Now, an important part of particle physics is the ability to calculate specific charge. Specific charge is the ratio between charge and mass. So to calculate it, we divide charge by mass. Let's try that out. Calculate the specific charge of the nucleus of hydrogen. We know there's 1 proton and no electrons in the nucleus. The charge of a proton is 1.6 times 10 to the minus 19 coulombs. There are no neutrons, so we just need the mass of the proton, and that's 1.67 times 10 to the minus 27 kilograms. Divide 1.6 times 10 to the minus 19 by 1.67 times 10 to the minus 27, and we get the specific charge of 9.58 times 10 to the 7 coulombs per kilogram. Let's do another. Calculate the specific charge of the electron. The electron has a charge of minus 1.6 times 10 to the minus 19 coulombs and a mass of 9.11 times 10 to the minus 31 kilograms. So its specific charge is 1.76 times 10 to the 11 coulombs per kilogram. The electron actually has the largest specific charge of any particle. Calculate the specific charge of an ion of the magnesium isotope with charge plus 3.2 times 10 to the minus 19 coulombs and mass 3.9 times 10 to the minus 26 kilograms. So we divide charge by mass and we get 8.04 times 10 to the 6 coulombs per kilogram. Thanks for watching. If you have any questions, leave them down below and I'll do my best to answer them. Don't forget to check out my Google Docs folder, link in the doobly-doo, and as always, I'll see you next time.